Okay. Can you guys hear me? Testing, testing. Let me know in the chat if you can hear me. I'm gonna ping the Discord. Um, hey, Bacon, Stefan, Catsment. You guys hear me all right? Catsment says yeah. Let me pull up the book. This guy. Awesome. Xylo can't chat. You guys obviously are able to chat, right? So all right, I'm gonna go ahead and get started here. And yeah, Xylo's having some technical difficulties. Hey, let me know. There's on the live stream, uh, settings. There's like normal latency, low latency, and ultra low latency options, so that the chat is more in sync with the video, right? But I think it reduces the quality of the video, obviously, to be able to do that. So let me know. I have it on ultra low today. Let me know if the quality is like too low or you're not able to read text and stuff. I can blow stuff up pretty big for you, but just let me know if like the quality's too low or something. You can read. Cool. Thank you. All right, I'm gonna start. So we need to jump into here. Let this load. Oh, I said I was going to tell you guys about my backpacking trip. So I was supposed to get back on Tuesday. I got back last night at like 10 o'clock, right? And we started, it was going good. It was like super pretty place in the middle of Pennsylvania, and it was beautiful. And first thing that was sort of wrong is that we forgot fuel. So we had to make dinner over the fire, which is fun and fine. But then it started pouring rain on us, and so we got really soaked while we were hiking the one day. But that wasn't really a big deal either. But then the next day, like the afternoon of the second day, we'd already hiked like 30 miles from our car, and so illiterate. But my foot started hurting. My arch, like the arch of my foot, started hurting really bad, and so I, and then both of us also started feeling. It was me and my cousin started feeling bad about not being back here because we were missing 2 days of work, and so we just started thinking about coming back, and then eventually we just decided to jump ship and come back, and so we hitchhiked back to our car, and a nice guy gave us a ride like 25 miles in the bed of his truck. And then a young woman took us in her car the last like 15 miles or so. So we managed to get back. Hey, Xylo's here. So that's why I'm here on Monday and not a Wednesday. So, all right, I'm gonna jump in. Yes, hitchhiking. That was my actually first time hitchhiking. My cousin had done it before, but it was fun. There's definitely some horror stories these days about how it can go wrong, but we had pretty good luck. It only took us like 20 minutes both times to get somebody. Okay, so I had set myself up for hello, Neovan? You pick everybody up. That's awesome. Yeah, I'm much more sympathetic now towards hitchhikers that I've had to do it myself. Wait, what's this? Yeah, so we copied all this over. This is where I need to be doing the work. Okay, cool. So we don't need this anymore. All right, so last time we like installed Python 2, right? So that we could run these tests. It's been a little bit. So we did like well, I need a cd into source assignments 1, right? And then we have and then student. And then oh dear. And then we could go like test.py, right? And that would run our test. Just checking. You guys can see. Yeah, cool. Okay. So fail. Testing. So string length is failing. Was that one of our? Let me reread this assignment instructions really quick so I actually understand what we're trying to do. Edit lib. I renamed it to lib.asm and provide definitions for the functions instead of the stub xor rax. Refer to table 2.2 for the required function semantics, which is this guy, right? Okay. We do recommend implementing them in the given order. Okay, so we're just going to work through this table and implement these functions. What's a little bit annoying is that this test isn't like testing them in this order, right? Because this is testing string length, which is, oh, I guess that's the second one. Okay, so that's not bad. We need to make an exit one first. Accepts an exit code and terminates the current process. And then we're supposed to use test.py to perform automated tests of correctness. Just run it, and it will do the rest. Remember that a string of n characters needs n+1 bytes to be stored in memory because of an null terminator. Yep. Read appendix A to see how you can execute the program step by step, observing the changes in register values in memory state. You don't think you can see what I'm looking at? Hey. Is that so? Hey, that is what it looks like on OBS. You're right. Yeah, you see terminal. I see a terminal and my book. Here, 1 second. Let me try something here. All right, now do you see a big black nothing, an abyss? This will be my big term or big. Cool. Okay, I'm gonna add it. 1 second. Oh dear. Sorry. How is this? Is this working? Can you guys see this? Awesome. Okay, I didn't really do anything. I just SSH into the code space, and then I read like this like paragraph right here that just explained what to do. Silo can't see anything, but the rest of you see it. So that's probably his issue, right? Okay, you guys can see. All right, I'm just gonna keep going. So, and then I read. Oh yeah, and then I read this too. Okay, so we need to jump in. Wait, why? Maybe like exit isn't on this list, and it's also not being tested because it tested string length first. So maybe, not sure what this is for. Oh, now it's back for silo. Perfect. All right, we'll start with string length. So we need to. Okay, accepts a pointer to a string and returns its length. So we kind of already did this, right? And so I could go back and look at that code, but it might be interesting to try to do this from memory or from, yeah, not by looking at that. Let me try that. Zoom in on the book a bit, sure. I might have to shrink that over. How is that? Is that better? So I need to think about how to make this function. So terminal looks good, great. Accepts accepts a pointer to a string and returns its length. So the pointer to the string is gonna go in the first argument place, right? Which is RDI. So takes pointer to string and RDI, exactly. But I want to turn off copilot. Copilot disable. Thank you. Okay. That's better. Awesome. So it's gonna take a pointer to a string and RDI, and then it needs to like loop through string until null terminator, right? Which is just 0. And then yeah. So if I wrote that in like pseudocode syntax, maybe that'd be helpful. I don't know. Well, I don't know. We'll just try it. So what's the So I want to set up a pointer. Or sorry, not a pointer. I want to set up a counter for this loop. What's the like? Is there a register that's traditionally or like conventionally used as a counter? I think RAX was used once, but I feel like something else was used too. If I want to set up a counter in NASM assembly x64, what register should I use for that? You can use any of them, but commonly used ones are RCX. RCX is commonly used, looks like. Use the chart. Which chart? Let me get a browser up here. This one. It honestly doesn't matter. Okay. RCX is the most used. That's what this guy said, right? RCX. So maybe I'll go with that. RCX. All right, so I'm gonna initialize. Oh wait, and then where's my chart again? Because RCX. Okay, cool. And then RCX, I am free to mutate as much as I want inside of a function. Okay, cool. I think that's what that means. So I'm going to initialize it to 0. I guess you can do that with, how you do it like this, RCX. Okay. I can get rid of that. So that initializes it. Initialize counter to 0. All right, and then as an exercise, you should print hello world 10 times with a loop. Should I try that first? I'm up for trying that. Sure, that actually does sound helpful. Let's try that. All right, here we go. Hello 10. All right, here we go. Hello 10, ASM. This is going to print hello 10 times. I'm going to like get some boilerplate. Okay. So this is gonna be, I'll make like a function. Where do we? No, like yeah, like this kind of thing. Okay, so the start or conventionally starts with an underscore, but these don't start with underscores. So that, I'm assuming that's just convention. Okay. All right, cool. So hello 10. I'm gonna make a function called like print hello. That will. Can I make it my hello be right here? There we go. Hello. Everybody start both work. Okay. Print hello. It'll print hello basically does this, right? It just move rx1, so this is to right. And then move RDI 1. This is for standard out, right? And then RSI message which is our hello, right? And then, okay, sure. And then we do that, and then we do a syscall, right? Oh no, we need to do the rdx thing too. Move rdx, and now this is right 1, 2, 3, 4, 5, and then 6 with the new line. So 6, and then syscall. So this will print hello. So if I did this down here, I could just say call print hello, and I need to remember to do this, right? Okay. And then exit, right? So exit, we'll do this, we'll move into RAX 60, and then move into RDI, or I guess we can XOR RDI, RDI, right? And then syscall. And that should exit. Let's try this. Where's my terminal? Okay. I'm going to, no, it's all the way through, right? Back in the scratch pad. Okay. ELF64. By the way, is the volume okay? I can move the mic closer or farther away. Or change the volume, whichever you guys, whatever you want. ELF64. And then volume's good. Okay, cool. Hello 10, right? Okay, hello 10, and then -o hello 10.o. That worked. All right, and then elf, a little quiet. I'll move it a little closer. How's that? Elf. No, what am I doing? Elf. Link ld hello 10.o, and then -o hello 10. All right, and then if I run hello 10, I get a seg fault. Okay, so I did something wrong. There's a seg fault. Now I have to debug this. 2, 3, 4, 5. So this is the code for the write sys code. This says to do it to standard out, write to standard out. This just tells it what to write. And then this tells it how many bytes to write, right? Which is 1, 2, 3, 4, 5, and then 6 with a 10 here. And then we do the syscall and we return. And then down here we, oh, maybe this section text, maybe this needs to be here. Does it? Because this is part of that, isn't it? Maybe that's it. Let's try it. Oh, sweet. Okay, that was it. Awesome. So that works. Now we need to do that 10 times, right? So I'm going to jump over here. We'll say down here, I guess I'll make a, what are these things called? What are these called? Labels, I think. Labels or marks, or I think they're labels. Yeah, now just do it 10 times, right? So I'll make a label. I'll make a label called loop. This will just be like the start of my loop. And then loop, I'll set a, okay, up here I'll set a counter. I'll use RCX, right? So I'll say set that to 0, RCX, initialize counter to 0. Cool. And then I'll loop label. Well, that's kind of obvious, I guess. There's a few ways I feel like I could do this. Okay, so this'll that's kind of obvious too. So okay, so I can compare RCX with 10, right? And then okay, so then jump if not equal, right? Yeah. Okay, jump if not equal to loop. Is that correct? Do these need to start with a, I feel like I've seen this. Did I, not sure about that. Okay, I'll try this first. So jump to there. It does need to start. Okay, dot loop. Like this or like that? Only here? Do I only need the dot here or do I need it here as well? It's good. Okay, so like this. Okay, so jump if not equal to there. Otherwise, okay. So if they're not equal, it'll jump to here and do it again, right? It'll print it again and it'll compare them. Otherwise, it'll get through here. And then I could have like a jump to like the end or whatever, but that it'll just fall through to here, no? So I don't really need that. If JNE doesn't execute, it will run it, right? If JNE doesn't execute, it'll just go through here. But do I need to create a new label, right? Because won't it just fall through? And this is what I wanted to do anyway. Or am I not thinking about that right? I don't need to. Okay. So it's considered good practice. All right, I'll try. Jump to the end, and then we'll call this the end. I think that's right. Is JMP the right command here? Let's just try running this. We'll do nasm and then, oh dear. Symbol loop.loop is undefined. Maybe I do need, do I in fact need that there and that there? I don't need that. Okay, so I just do that and let it fall through here. Okay. Oh, that works. Help. Stop. Oh dear. I froze the terminal. Alright, so I clearly made an infinite loop. And everything's frozen now. Alright, I'm not sure what to do here. Let me just do this. Try this, go here. Let's try that again. Where was I? Hello. Scratchpad, right? Oh dear. I was in here. Let me look at another one where I had a loop, because didn't I have a loop in like this one? You think I need to increase RCX? That's a good idea. Oh man. Yeah. Okay. So did I hear right? So like yeah. Thank you. But I want to turn off Copilot. Copilot disable. That'll do it. Why'd this line go invisible? There we go. Now it's back. Now it's gone again. There we go. It's back. Let's try this. Terminal. Let's go in the scratch pad. All right, Nazem. Is it still in my history here? Yeah. That guy, and then link him, and then try that. Oh no, it's doing it again. Okay, I caught it. That is still not working. You can also do move RCX10 and then loop.loop, because that handles the CMP and decrementing RCX all in one. So it's like that. So the other loop I saw over here, this is kind of doing it the other way around, right? Like if they're equal, jump to the end. And then always, if they're not equal, just jump back to the start of the loop. I could try that. I don't quite get why this isn't working. So that'd be like this, right? Like if these guys are equal, jump to the end. Oops. Jump to the end. Sorry, jump if equal. And then this would be jump to the loop. Although why in the world do these lines go invisible sometimes? Okay, this is how I had it before. Jump if not equal. Okay. Should I try debugger? No. Increment after J and E. Like move this guy down here. That's not right though, is it? Because then we'll never increment. Because it'll always get skipped when we jump here. I don't think that's right. I think we need to do it up here. Try it? I'll try it, but I'm almost certain this is gonna loop, won't it? I'll give it a go. NASM. Yep, it's infinite. Oh no, I froze again. Cool. Yeah, I'm pretty sure this needs to go up here. All right, I want to give a debugger a try. Because I've used lld, wait, what's it called? Yeah, lldb. And it was kind of fun. So I want to try that. So I'm going to go to terminal. First of all, oh sweet. I do not remember remotely what the commands were. lldb. That's what I had. Okay. So if I were to just like lldb hello, wait, where am I? Oh, I need to go into Scratchpad. Okay, lldb hello 10. Cool, and then can't I say like run or step or something? Maybe I have to do run first. Yeah. Run. Okay. Stop it. Thank you. So I need to make a breakpoint first. Yeah, okay. But do I have to breakpoint? Don't you breakpoint and then run and then it'll run until it hits your breakpoint and then you step? I think that's what I remember. So where do I want to set a breakpoint? Like right here, right? Like line 16. Do I have to, because is there a way to build with debug symbols? Do I need to do that or not? All right, let me try this. What was the project I was doing this in? Active projects, Fizz, I think is what I called it. Okay. And then if I like that. Debug symbols aren't that important. All right, I'm just trying to find the, here we go, this breakpoint thing. Cool. So I should be able to, so I went at line 16, right? Okay. So I should be able to say, let me try this. Where am I? Why can't I type? Sorry. New of them troubles. Okay. Scratchpad. This guy. Right? Okay. And then terminal. Awesome. So I'm gonna go lldb hello 10. Oh wait, I'm not in the right place. cd scratchpad. And then lldb hello 10. Okay, and then I need to set a breakpoint. So I go breakpoint set. You like the way the other code did it? Jump until 10 and then JE out of the loop. Okay, we can try that in a second. And then the file is it's hello 10.asm, right? And then the line The line was 16, right? Right here. 16. No locations. Unable to resolve breakpoint to any actual locations. That's not good. Does that mean we need to... breakpoint main? Like literally just type that out. Breakpoint main. Breakpoint 16. Yeah, that's not working here. Is this where I need to... I feel like I need to build with debug symbols to be able to do this. I think I remember that from before. I could be totally wrong though. But maybe I should just try it. How to assemble with debug symbols. Okay, you have it there. Dash G is what I remember too. Okay, let's try that. Stop that. NASM L64 dash G. What's the dash F dwarf? We can try without that first. So we're not trying too many things at once. Dash O. Oh wait, no, we need sorry, Xylo. Hello 10.asm and then dash O. Hello 10.0. That did something. All right, and then we'll do the same link command, right? This guy. Should be able to do break start. Okay. And then we'll try lldb hello 10. Okay, and now if I try, well, let me first try this guy. No, that still didn't work. Break. Oh, so try it with the dash F dwarf. All right, we're gonna try the dwarf. Dash F, no, big F, dwarf, and then link it, and then lldb it. Okay, and now, oh yeah, that worked. So the dwarf was necessary. So now if I run, oh dear. That's not what I wanted. All right, let's try that again. lldb. Oh no. Sorry. Okay. I had it. It looked like I had it there. lldb hello 10. All right, and then I do the breakpoint set. All right, and then I can also do that. Oh, thank you. That's helpful. Um, okay, now do I want, because when I hit run, it just ran forever again. Can't you also just do like step? Maybe not. SI? No. Because I think you have to run it first, and then it'll go to the breakpoint, stop, and then you can step from there, right? But if I hit run, then it runs forever. So is my breakpoint in the right spot? My breakpoint is right here. Breakpoint on line 17. Okay, we can try that. lldb, that guy, and then try the breakpoint, but on line 17. Here we go. Nope. That's interesting, but that's just because I stopped it. Hey, Alan. First time watching me live and following my OS journey. Thank you. I wouldn't say it's much of an OS journey yet, but it's definitely been a journey, and I'm definitely trying to learn. So, appreciate having you here. Thanks for joining in. I'm hoping it will turn into more of an OS journey down the road, but currently it's pretty much just an assembly journey. And right now it's an lldb journey. Let's see. Okay, so something like, what if I literally set the breakpoint on the first line? That's not a bad idea. Big boy tutor. How about you try the working loop example and you debug that to see how it works? Let me, how do I, oh yeah, okay, there we go. Let me try one more thing. lldb hello 10. First line may not work. It's worth a shot. Yeah, I just want to try it and see if anything happens. Because this literally, if it's doing what I tell it to do, it literally shouldn't even run anything, right? Because it'll just stop immediately. And so if it loops after this, we'll pretty much know that it's just like ignoring my breakpoints, maybe? I don't know. All right, now if I run, oh yeah. That totally worked. Didn't that work? So now we're here. We're here on line 9, which is okay. Which is, I just need to, here, let me make this guy bigger so I can have them both. I can make this bigger too for you guys. Okay. Okay, I'm going to what was I gonna do? I was gonna do, how do you do this? like that. Okay. So now we have this open on the side. Hello, Mitchell. Welcome. lldb doesn't have a TUI. What, does GDB have a TUI? I mean, this is sort of TUI-ish. Okay, so we are right here. We blew past all of this, I guess, because they're not like actual commands, and we're sitting on the first real command. Why? Wait. Don't I want this to start executing here, not here? Because this is just like a function I want to call from inside of here, but I want to start executing right here, which is what I thought this does here. Like, because if I were to step now, yeah, it's chugging through this, which is not what I want. Print the register. So what register? Because I just moved, okay, I moved 1 into RAX. Let's try that one. How do you do it? Register read RAX. Sure enough, there's 1 in RAX. But that's not what I want, because I don't want this. I don't even want this to be running yet. So I feel like I did something wrong. Do b underscore start and then c for continue. Like in lldb, do that. b underscore start. Compare my program to the previous loop example. Sure, let's try debugging like a example that we know works, maybe. I liked that suggestion. Let me just get rid of that. Okay. So which one of these has a loop and we know it works? Sterlen does, right? All right, get rid of that. This thing we know works, correct? We have 1, 2, 3, 4, 5, 6. Let's just try it really quick. Sterlen. And then 8. Maybe I didn't compile it. Nasm -f elf 64 sterlen.asm -o sterlen.o, and then ld sterlen.o -o sterlen. There we go, 6. That's what we wanted. Okay. So this is good. So now I want to do the same thing, but in here, let me do this. Okay. Let me set or first I need to do this, but in with debug symbols. So like -g, and then what was the other one? Or not there. Or I guess maybe right here. -g -big F dwarf. And then link it. And then, yeah, okay. And now lldb sterlen. All right, now I want to set a breakpoint. Where, what line? I don't know, the first one, see where it goes. Try that again. That did not work. Probably because I have the wrong assembly file here. This should be strlen. There we go. Now if I run, where is it going to stop? See, this is doing the same thing. It's stopping there. The order of the flags don't matter as long as you have the right args after each flag. Yeah. It's going to the first instruction in the text section because why would you break on data? That makes sense to me. What doesn't make sense to me is why isn't it starting here? Break to main or start. But doesn't lldb just like go through and execute the program in the same way that it would execute like if I just ran it normally? And if it's running normally, I do not want this to be running first, right? Or am I confused about that? So you're saying I should set a breakpoint right here? We could try that. So it'd be this, and then okay, line 20. All right, now run. Yeah. What is this? Executed with status 6. Instead of line 20, write start. Okay, let me try again. Try again. Breakpoints like what? Or wait. This, and then instead of line 1, just try start? Or is there another flag? That doesn't work. Dash dash label. Nope. With lldb, how do I set a breakpoint on, oh, just break start? Like this? Nope. We got that. Dash dash name. Dash dash name seems to be the thing. Breakpoint set dash dash name start. Oh yeah, that worked. Now if we run, sure enough, we're somehow already right here and we didn't do this. That seems a little bit funny, doesn't it? sitting right here. And we already did this. Whereas I wanted to stop here and hopefully stop here. Alright, well, what's an RDI? Register read RDI. Oh. Well, this is really cool. It actually shows test string. That's interesting. So this is the pointer to test string. I'm not sure why that already ran, but that is what we want. So then we call, so now if I step, it calls strlen, and so it jumps up to here. All right, now if I step again, it jumps to here and says, compare these things. But first, it should have set 0 in RAX. So if I register read RAX, sure enough, it's 0. Okay, so now if I step again, we're on this line, right? So we just compared RDI offset by RAX and 0. And where does the result of this go? Doesn't it set some flag? And if so, what is that flag? Where does the result of CMP go? Like, how can I see it in lldb? Yeah, I know that. It's not stored in register memory location. Instead, it affects the status flags in the E flags register. So you can expect those flags. I already did that. I already did that. Register read R flags. Wait, inspect the flags. Once the program hits the breakpoint, you can inspect the flags in the E flags register using the register read command. Look specifically at the 0 flag, signed flag, and carry flag, as they are typically affected by CMP. So there's a 0 flag, a signed flag, and carry flag. So let's check the 0 flag. Register read R flags. Two, 0, 2. What in the world does that mean? 2, 0, 2. Well, at any rate, if I were to step again, they're not equal. And so we go to increment RAX. Oh yes, and then if we step again, it should have incremented RAX. So if I register read RAX, it should be 1. Sure enough, it's 1. Then we jump to loop. So we step, and sure enough, it jumps back to loop. All right, then we do this again and again and again and again and again and again. Oops. And again 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 and yet again and again and again. Oh, and this time it jumped. Okay. Move. So we jumped out of there, and at this point now, if I register read RAX, it's 6, because we went through that thing 6 times, because there's 6 characters here. Okay. And then now we're down here, and we're moving that value into RDI, so we'll just do that. So now this thing should be in RDI as well. 6, sure enough. All right, and then we're gonna do the syscall thing, so we can step, and now REX should contain 60, which is 3C, which is like 3 times 16 plus 9, 10, 11, 12. Sure enough, it's 60. And then we're just gonna syscall. So we'll step, shoink, and process exited with status of 6. Okay, that's cool. So that totally worked. What totally didn't work was my own handy little program. So I guess now we need to try it with mine again, because we know that this one works. So I think we already nasm dash, what is it? Nasm. That's mine. All right, and then link it. All right, a little behind on chat, sorry. I can print a decimal, okay. We'll let you check the mem there. Thank you. Your video series inspired me to learn ASM, low, level C, and OS design. I've been learning a whole lot about operating systems and how it works, chip design, CPU architectures, and more. Awesome, that's super cool. Yeah, I've been learning a bunch too. And haven't gotten super far yet, but it's been super fun. Yeah, welcome. Very welcome. Should have a dot end. Okay, that is what this one had, right? Like this kind of thing, that's what you're talking about? Yes, yes, okay. Let me jump over here and jump into this thing. So you're telling me, see, the thing is my loop isn't inside of a function, so I don't need the return statement, right? Maybe I do. All right, but we said we were gonna try this in the other style, which was like the, if it's equal, jump to the end. Otherwise, jump back to the loop. All right, so we're gonna say, wait. So I compare these things here. And then, sorry, if they're equal, jump to the end. And then we do our thing here. And then we're gonna jump to loop, right? Disable. Return at the end, not inside the loop. Like where? The other thing I could do is like make a loop hellos function, if that might make it easier to reason about. Maybe I should do that. What would that look like? Something like this. And then it would make more sense, I think, to use just the return thing here, right? So I kind of like this better, actually, doing this. So then here, all we do is, oh, this needs to jump up into here, I think. And then here we're just gonna say call loop hellos. RET at the end, not inside the loop. It should be the last instruction. It's the way the call stack works. Look at the other program where they put their RET. You mean this guy? But this is like the final thing in this whole function, isn't it? And so that's kind of what I have now, right? This is the final thing in this whole function. But before that, I didn't have, I had all this like inlined down in here. So I think I'm good now. Yeah, okay, I got it. Thank you. Except this is the wrong file. Okay, there we go. So now I'm saying, okay, in start, all I do is I call loop hellos, okay? That should jump me up to here, which will jump me down to here. I initialize RCX to 0. Then I compare that with 10. If they're equal, so if it's already to 10, then I jump to here, and that'll just get me out here, and we'll exit, okay? Otherwise, I'm going to call print hello, which should just print hello, like it says. Then I'm going to increment my counter by 1. Something tells me you will print only 9 times. Very likely I will have an off by 1 error, but that seems like a secondary concern right now. I'm just trying to print less than infinite times right now. And then I increment that, and then I jump to loop back to here, and then we repeat, rinse and repeat, right? I'm thinking this should work. So let's just try running it. Maybe try running it without, well, it probably doesn't make a difference, does it? But let's just try it without these just in case. And then link it, and then hello 10, cross your fingers. Nope, it's infinite. Okay. So now we're going to try the debugger. So I'm going to now build it again, now with debug symbols, do that. I'm going to lldb. Excuse me, lldb hello 10. Now I need to set a breakpoint. And what did we do? We did breakpoint set, right? -- name _ start. Ooh, that worked. I don't know if it's correct to have RET in print hello. I thought, okay, correct me if I'm wrong on this. I thought that RET, I can use B for short, thank you. When okay, where am I calling it? Right here, right? I'm calling print hello right here, right? When I do this, it sticks RIP onto the stack so it remembers where it was, right? Like to save its spot. Then it jumps over to here, runs this. And then when it does RET, it pops it back off the stack. And what that does is it resumes this spot, right? And so I need to do that, right? To be able to get back to this spot. And so I think that's why we need to do RET after any function. But I could be totally wrong about that. That was in response to you don't know if it's correct to have RET in print hello. Just joined. Do you check whether syscall modifies RCX? Did I check whether syscall modifies RCX? No, I didn't. But that would totally mess me up if it did, right? Because I'm doing a syscall on this line, right, implicitly, and then I'm checking RCX, right? How did I know that? I don't think that's in my handy chart. It would? Oh no. That's actually kind of funny because that would totally explain my problem. RCX, see, this doesn't say anything about syscalls. See what the debugger says. All right, let's see what the debugger says first. All right, now I'm going to run. No, look, it's already looping. See? It's not even, yeah, something funny's going on. All right, but I like what this guy said. Does so in x64 NASM, do syscalls modify RCX, right? Is that the question? It's not preserved across the syscall. This means that after the syscall is executed, the value in RCX may be modified or overwritten. That is very interesting. What's the syscall I'm doing here? It'd be a write, no? Will the live be saved on the channel? Yes, it will be saved, and you can watch it for free, and it's fine. It'll go. I think it'll automatically go to the end of the playlist. I just have to like upload a new thumbnail and stuff whenever I finish. Okay, so what we could do, that'd be interesting, is maybe make like a test, rcx test.asm, because I want to see, like, just copy all this for now. I want to see if, no, this guy, I want to see if this actually changes. So thanks Entcraft. Yeah, I think that guy might have just saved us, but we're gonna test that out really quick. Xylo says to use RBX instead of RCX on Discord. Oh, are people talking on Discord? Use RBX instead of RCX. Tell him to see Discord. Okay, I'm looking at Discord now. Sorry, Xylo. Use RBX instead of RCX. Should we just try that really quick? So where's our thing? Right here. Hello 10. Where am I using RCX? Right here. Okay. RBX. That didn't work. RBX. All right, so now we're using that as our counter. Oops. Okay. Oh. Wait. Big Boy Tutor is Astro? Is that correct? Things are starting to come together in my mind now. Or you can preserve the register before the syscall. Ooh. That's another idea. That seems kind of clean too. I'm not sure which of those would be. Okay, you're Astro. Okay, awesome. That makes sense. I was wondering. I was like, what is this guy, and why isn't he on the Discord? But okay, you're Astro. That's cool. What was I trying? Okay, I was gonna try this with the new. First, I'll try it with this new register RBX, which according to Xylo, at least won't be corrupted by the syscall, and then I will try saving it. You may want to do it for RBX as well in case the same thing happens. Sure, I'll try it. If this doesn't work, I'll try that. Okay. Nothing's working now. Hold on. We're in Vim troubles again. There we go. This is weird. Hello? Okay. Vim was really breaking. We wanted this guy. All right, at least it's saved. So RBX. Oh, Xylo's finally back. Thank you. Welcome. Terminal. Okay, and then we were gonna do Nazum. Should be saved somewhere. This guy, right? But let me get rid of these just in case. And then that's because I'm in the wrong place. CD scratchpad. I'll try that. And then link it. Moment of truth. Oh my word. Okay, so it's totally that. We need to have some sort of reward system for Entcraft because he just totally saved us. How many is this though? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's not even an off by 1 error. Can you believe it? You preserve it by doing something like push, sure, and then pop it afterwards. I kind of want to try that because I like that idea. And it sounds fun. So AI Life, hello, how's it going? I've also started to read books now. I'm going with operating system 0 to 1. I haven't seen that one, but awesome. Yes, okay, awesome. So RBX is good, but I want to try. So it did say, people seem to say that RCX is more commonly used as a counter. For that reason, I'm going to go back to RCX and then try to save it, right? So it'd be like right here, because it's going to be corrupted. RCX, wait, hold on. Copilot disable. All right, is corrupted right here. So I need to save it here by doing push RCX. And then down here after this, I can pop RCX, right? And then that should pretty much solve our problems. What line is here that's invisible? Excuse me. And then I can increment it, right? So this should work just as well as the other one, except it might not be quite as efficient, right? Because we're pushing and popping to the stack. Wow, it's confusing memorizing like which registers get overwritten and which ones don't and stuff. That seems kind of hard. At least there's like tables and stuff. So I like this though. We're gonna try this, see if this works, because that'd be interesting. Do that, and then do that, and it totally works with the push pop dance too. Awesome. Super fun. Use the XMM registers. Well, at least probably. I have no idea what that even means. All right, now can we get to a real assignment? Because this was all just but I'm glad we did this because this was super helpful for learning reasons. All right, moving on to the real deal. We've got string length, which we already have sort of, but you know. Takes a pointer to a string in RDI. All right, we have, let's check on the stream. Stream still looks good, right? Okay. Time to teach Kai about SIMD, exactly. I don't think I'm quite there yet. Takes pointer to string in RDI. All right, so we have, what we have is in RDI. Excuse me. We have a pointer to a string that ends with a 0, right? This is our null terminator. We did learn a ton this stream, or at least I learned a ton. You guys probably didn't learn a whole lot, but I learned a lot. And now I need to see how long it is. And it's basically the same thing that was in the other Sterlen thing, right? So I'm going to set a counter, which is what I did here. And then I'm going to make a, what am I going to do? I'll probably end up running like a loop label. And then like in the loop label, I will Bacon's got to go. All right. See you, Bacon. Thanks for all the help. Okay, in the loop, what do I do in the loop? I need to, hang on, let me think about this. Okay, so the one thing that's funny, I need to do that weird offset thing, right? Like this thing. I'm gonna steal this. It's like this, except for I'm using RCX, right? RCX. And this goes into RDI, the memory where RDI is pointing, but offsets it by our counter, so we're looping through. checking if it's 0. I can already tell you that telling you to write a basic hello. Yeah, Xylo, thank you. That was super, super, both fun and educational. I don't know if I would have been able to do this. Well, I still don't know if I'll be able to do this, but I don't think I would have been able to without doing that. So, although, oh yeah, we're good. So then we compare those things. If they're equal, that means we found the end and we're done, right? Okay, so if they're done, so jump if equal to end, and we'll make end, okay, end is gonna be like this, right? Dot end. Okay, if they're not equal, so that means we'll be down here on the next line, we fall through, then we inker, right? We can inker. Is that? No, just ink, right? Ink? Is that it? Ink. Yeah, just ink. Okay. Ink RCX, our counter. And is that all there is to it? If I passed a string like hi and then I had like the 0 here at the end, right? Then we'd say RCX is 0, and then we compare okay, so if I had like RDI equal to I 0, we'd have 0, right? And then we'd have RDI 0 would be like the character H, right? We compare that against 0. It's not, so this is false. False. And then excuse me. We'd get false. Then jump if equal, so they're not equal, so then we'd increment it, we'd get 1. Oh, I need to do here. Okay, jump to the loop. Then we jump to the loop, and then we'd compare them again, so we'd get RDI this time 1, which would be I, and is it 0? No, we'd get false. And then we'd say, okay, they're equal. Do we jump? No. And so we'd increment RCX. Then we get 2. Then we jump back to the loop, do the same thing, right? Try 2. But this time we would, in fact, get the null terminator. Is it equal to 0? Yes, we get true. So they are equal. So then we jump to the end. So then we jump to the end. And then we return, right? So that, in my opinion, oh, where do we put the answer? Because now RCX has the length of the string. Make this more educational. Try printing the number with hello, hello 1, hello 2. Oh, with hello 1, hello 2, hello 3, so on. Okay, not a bad idea. But let me just try to get this real quick. All right, I might have an off by 1 error, but we'll give it a shot. I think this might even just work. All right, hello. What do we do now? Oh yeah, we have to run that like Python script. Test. String length on that. It compiled. I don't understand what this even means. I feel like I'd almost rather write my own tests than use this Python thing. That might be a bad idea though. Because what does this mean? Yeah, this definitely isn't very intuitive. Like, what's the 255? Like, it makes sense if this was like expected got, right? But this is clearly not what this is, because this is an empty something, and this is some number. I mean, I could just make my own like test cases for these things and just build the same functions, but like with my own. It's trying to show length, but that means it's not getting the length. Yeah, it's two. Well, it's 2 to the 8th minus 1, right? But then why? Yeah, I don't get it. What do you guys think? Should I just make my own, just like example files for like testing these things, or that might be fun. I think I might just do that actually, because I don't really want to have to deal with this thing. All right, I'm just gonna make like a. Well, I can just do it right in here, right? So here's my testing. It'll be here. So I'll say like dot here. I'll say global start. Good exercise at the expense of time. Yeah, I don't think it'll take a ton of time, right? I'll just have to say. By the way, did this returns its length? Like when you say return its length, what register do I put the length into? Or red and rust? Good idea. We'll make it blazing fast while we're at it. Except the pointer return its length. Yeah. Do you guys what do I do with return value? Is there a convention about that? Like, is there a certain register that return values go into? Maybe that was in my handy chart. Who knows? Oh, look at this. Return value goes in RAX. Aha. All right. That problem is solved. So I need to then move RCX into RAX. Sorry, other way around. RAX into RCX. Alternatively, we could have just used RX the entire time, and then we don't have to do that. Not a bad idea. Use the chart. I used the chart. I figured it out. That might be more efficient. Let's do it. RAX. Why is this not working? RAX. 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 And then we don't have to do this, because it's already in RAX. Okay. And then down here, here's my test, right? So it's just going to be the start. I'm just going to say, okay, I need to make like some test cases up here. So I'll make like a section.data. I'm going to say tester1 is going to be some string like hello world. And then it needs to be null terminated, right? So I do this, no? You need to memorize the calling convention at some point. Okay. Hello world followed by 0. I think that's all I need there. And then here, I'm going to say move RDI. What did I call it? Hello test string 1. Okay. Test stir 1. What am I even watching? I don't understand nothing. I didn't either a couple weeks ago, and now I understand some of it. Move test string 1 into RDI. Oh yeah, and then we just will what do we do? What's it called? String length. Okay, string length. We do call string length. And then we're going to we'll print, well, I don't know, what do we do? Something with, how are we gonna see what RAX is? We can move, we can make that be the exit code maybe. That way, while testing, wait, it may be good to isolate functions step by step in a separate file and complete them that way while testing them yourself. You mean as opposed to having them all like lumped together in this giant file? That does sound nice. I'll probably do that. Let me just test this one real quick and then I'll break them up. Okay. Let me see here. Print it like a string with length 1. Print RAX, you mean? Hey, ICXD is here. Welcome. Print it like a string. So I have some number. If I print it like a string, it's going to be some ASCII character, isn't it? And then I'm going to try, let me just try the exit code thing first, and then, so I'll move, oh wait, RX has my value now. So let me move, wait, but RAX also holds the, right? RAX holds the, yes, this. All right, so let me store like my result temporarily, maybe in, or my exit code. Which one holds the exit code? It's RDI, right? So I'll do that, RAX. And then I'll move into RAX 60, and then I'll syscall. So we're gonna, sooner or later, you'll want to learn how to call asm from Rust anyway. I know, but I don't feel like I'm quite ready for that yet. Might break the momentum a bit. Yeah, I feel like that might be true. Is this right? So I'm gonna stick the exit code. Well, the length of the string goes in RAX, and then I move that into here so that it's the exit code, and then I move 60 into RAX, and then I'm gonna syscall. Okay, so we're gonna exit like that. Let me try that. Where am I? All right, I'm gonna nasm -f elf64 lib.asm, and then I'm going to -o lib.o. Then I'm gonna link it lib.o -o lib. I'm gonna run it, and then I'm gonna echo this. First of all, what are we expecting? 1, 2, 3, 4. Wait, hold on, I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 maybe, and 11. Sure enough, it works. Cool. That's really nice, actually. Oops. So, all right, and then it was recommended to me that I break these apart a little bit, which I thoroughly agree with. I wonder if I could almost just see. There's no point even being down inside this. Deep thing. Let me just. I'm gonna make my own assignments one. Assignments. And then I'm going to, okay, then pull this guy up into, or wait, I don't need to do that. Do that. Oops. Okay, do that. All right, this is getting kind of messy. Okay, and then I have this. So I'm gonna make a new one called like stirlen or stirlen.asm. Well, actually, let me make like assignment 1 maybe, like 1, and then I can move both those up in there. Okay, stirlen. Making great progress. Thank you. Stirlen is pretty much this. All right, and then I want some stuff just to test it, right? So I take this, and then I had this, right? Probably still run the Python test for edge cases though until you write your own. Fair enough. Fair enough. But I will say that at this point, my interest is learning the assembly language and not writing perfectly correct code. And so I get what you're saying, though. I think I could go either way. All right, this should work, right? Except for that I can't see this. Okay. Let me get rid of this real quick. Okay. So let me now jump over in here. Oops. Oh dear, what's this? Okay. Where am I? Okay. Assignments 1. Here I am. I'm going to do the NASM thing. NASM-f elf 64 lib.asm and then -o lib.o. And then I'm going to link it. Lib.o -o lib. I agree wholeheartedly. But writing comprehensive tests in ASM would be too much, even though there's real good progress. Yeah. Okay, awesome. Thank you. So we have that, and now if I run, wait, sorry, I just totally compiled the wrong file. I meant to do the other one. See whether there, that was the thing I was thinking, are there assembly specific edge cases? Like where it's not just like a logic error on my part, but it's actually something I did wrong assembly wise. That's where I would be more inclined to run the Python tests. But I can always like copy pasta these over there later and then run them. So for now, I think this will be fine. At this point, run a shell script. That's not a bad idea. All right, smarter heads. Let me do a just file. I like just files. No, wait, snippets. Just file, boilerplate. I'm going to say, or maybe a make file. I'm gonna do just file. Run. I'll just like a run command that just runs a file, and I'll say like run or nasm -f elf 64 and that file goes in here, right? And then I'm gonna make it out, which would be like obj.o, and then I will link it. Obj.o -o. I'll call it like executable or something. I don't know. And then I'll run it. Can you make it so you can optionally compile in debug mode? When the time comes, I will do so. I forgot how. Yeah, I forgot how until the other day too. I think you do this, and then you just double squirrely them in here. And then it's pretty clean. I think personally, I think it looks a lot nicer than a make file. And then if you want to ignore the output, you do this. But I want to see any like errors and stuff. And then clean up, right? So like get rid of obj.o and exec. I should remove the edge file. Yeah, that's what. Yeah, just got that. Cool. So let's try using this thing. Oh dear. Oh dear. That's better. Okay. So I will just. Oh, I don't even have just installed. That's funny. It's probably just like a sudo apt install just. Yep, 10x productivity hacks. What sudo apt update? Hold on. Just 1 second. Where's just? Oh no. Don't tell me I have to cargo install it. Wait, do I have cargo? Oh, good. Okay, cargo install just. Chugga 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 choo. You can curl the binaries. Yes. Or you can wait for cargo to compile everything for you. Which is more fun? I don't know. Doo-doo-doo-doo. Good grief. 5 business days. Luckily, it's Monday. We have 5 business days. I'm starting to feel some more interest in your curl the binaries theory. Wait for it, wait for it, wait for it, wait for it. Patience, patience. I'm telling you, it's going to go really fast at the end. Maybe not, but it might. It's almost there. It's almost there. We're so close. Oh, yes. Oh, yes. Oh, no, it's actually doing it. Almost there. Come on, come on, come on, come on. Come on, come on. Oh, yeah, that's a lot of dependencies. Good grief. Yeah. I'm also on like a really the lowest end Linux VM that GitHub Codespaces offers. Yeah, before that, just compiles. Yeah, just compiles the dependencies. How's the stream looking, by the way? Are we still? Looks pretty good, right? Come on, come on. Oh dear, sorry, that was me. Come on, we're so close. Let's be real and accept that Rust is slow at compilation. Oh, I can accept that. It is very true. But isn't part of that like LLVM's fault? Oh, good, we're done. Okay. We got it. So now, what was that for? Oh yes, it's so that we can just what does this even mean? Recipe line has inconsistent leading white space. Recipe started with that, but found line with that. One of these has tabs and some of these have spaces. Sure enough, this one has a. Okay, these should all be tabs. Tab. Oops, that's too much. That's a big tab. That's spaces. This is spaces. That's spaces. And this is space help. Spaces. Okay. Well, I think either one is good. They just need to be consistent. I guess I could just do tabs. These are huge tabs. Who made these tabs? Oh, this is 2 tabs. Let's get rid of one. Like that. Okay. Now they're all tabs. They're all tabs. Try it again. Just. Oh. That's something else. Okay, so now I can just, what did I name my command? Just run. Okay, so I'm gonna just, wait, first of all, ls, where am I? Okay, just run strlen. Just, you're failing me. Unable to open input file strlen.asm. Why? It's right there. Dot slash. If I do this exact same thing, just straight from the command line right here. Oops. Then it works. The 10x productivity hack just wasted 20 minutes. Isn't that usually how it goes? But this is what it's running. This is what it's saying. Maybe because my just file is in the root and I'm down in here and it's confused about like where to find the file. That very well may be it. For the time being, let's try this. Put the just file in there where we need it. Oh yeah. That worked. Okay, see? It says error, but it's because it didn't exit with the 0 exit code. It exited with 11, which is precisely what we wanted. Yeah, it's running at the root there, exactly. Okay, so this is good. This is working. So 11, that's what we wanted. So our test worked. Now what didn't work is the cleanup afterwards because it terminated because it got a non-zero exit code. So I think we can resolve that. Doesn't like a semicolon just make it ignore the output and do this anyway? Let's try that. See, that's very nice, but now we don't have the exit code. So, last trick, we're going to do one more thing. Echo this here. Do this, right? Wait, how do you concatenate strings in bash? Exit code. What do you do? How do you concat strings in bash? Just like that. Space separate the args of echo. Oh, just like that? Let's try it. Oh yeah, that totally worked. Okay, we got 11. Sweet, that's perfect. All right, that's pretty nice. We'll stick with that. Okay, so strlen is good. Who's next on our list? We got strlen. We need to do print string, but where's my book? Print string accepts a pointer to a null terminated string and prints it to standard out. All right, that's pretty basic. I think we can do that. Let's copy over this for some boilerplate. Print string dot asm. I like underscores. Okay, print stir. Add some colors. Yeah, exactly. I need some colors. All right, print string. So often I'll just do the same test string, hello world. Section text. Okay, so we don't need this anymore. Here's what we're gonna do. I'll just write the test first. Test-driven development, people. It takes a pointer to a string and it just prints it, right? So we're gonna move our RDI, our thing into there, and then we're gonna call print string or print stir or whatever we call it, and then we're going to move. Then what's the? All right, so into RAX. Oh, print string is just gonna print it for us. All right, so then we just exit. So we could just do XOR RDI. Wait, is that what I want? No. Yeah, this is what I want. Okay, let me just do that. This is exit. Instead of hard coding the message length. Equal $ minus message. I have no idea what that means. Is the stream is still going. It's a long one. All right, so this is my test. What have you missed? When did you leave? We wrote our own stirlen. This thing, it worked. It was cool. And now we're doing print string. We're going through and we're doing these functions. So I did this one, and now we're doing this one. Okay, so now I need to write my function, because if I don't, it'll be mad at me. Print stir. So we know that inside in RDI is a pointer to our string, right? String. Oh, and we wasted 20 minutes on a just file, exactly. I don't think it was quite 20 minutes, but it was a little while. Mostly it was Cargo's fault. So RDI is a pointer to string. We need to print that thing. So we're just going to, oh yeah, this is easy. So we move RAX holds our code, which is just 1, right? And then we're gonna say like move RDI. Wait a minute. Oh, RDI already has the thing. All right, and then what are the other ones? So it's like RDI holds the pointer to the string, and then one of them holds like the string length, and then one of them says to do it to standard out. Check Discord. This thing? Okay, I'm just gonna hold off for just a minute on that Xylo, because I'm not quite I'm just gonna focus on this for now, but I will definitely check that out. Probably after stream, I'll check that out for sure. Thank you. All right, well, can I find something where we did some printing? Print call, what's print call? Print RAX. Where do I actually do some printing? Printing. This is a simpler one. Print new line, print hex, print new line. Here we go. So RAX holds 1. RDI holds, oh yeah, RDI needs to hold the standard out. Okay, so it's like this. Let me just copy this. Perfect. Okay, and then go back over here to print string. So it's like this. So 1 is the code for this. Now here's the problem: is that RDI currently has the pointer, so we need to move into RSI. RDI, no? And then we can get rid of that and then do this. And then RDX has 1. What does that mean again? I have no idea what that means. Oh, one of these is the length. Which one's the length? And which one means standard out? I think RDX is the length, maybe? Oh, it's all in hello 1, hello 10, isn't it? Print hello. RDX is the length. RDI is the length. That's what I thought. Okay. What did I say? RDX was the length? Is that what I said? Yeah, RDX is length. So this needs to be the length. Yeah, thank you. Oh wait, I see what you're saying, because I don't actually know the length right here. I don't actually know the length. So I do need to do what you suggested, no? Unless I just make this function take the length. Except a pointer to a string. That's all it takes is a pointer to a string returns. No, that's not this. Except a pointer to a null terminated string and prints it a standard out. Oh, unless I need to loop through and print it until I see the null terminator. Oh, okay. Is this more complicated than I thought? I think this is more complicated than I thought. I take a null terminated string, and I think I need to loop through each character and print it out. Does that sound right? Is that what I need to do here? Yes, okay. So that way we don't need the length, because we just go until we find the null terminator. All right, so this is different than I thought. So change your plans, change your plans. This should be the same, but I can't just do this so naively. So we still have the same thing. RDI is pointing to the string. It's really going to be quite similar to this thing, right? Okay. So I need to set up a counter. Sure, and who do we use for counter? We used, well, here we used RAX, but I think traditionally we use RCX, right? So I'm going to say initialize our counter, RCX, RCX. And then I'm going to have a loop, right? Loop. Oh, it's actually dot loop, no? And then you could, but syscalls are slow. Try to determine the length before you print. Okay. Well, I already have a strlen function, so I could just use that. See, would that be better? Oh, okay. That does make sense. They want you to use, it does say that, use previously implemented functions. Or use Xylo's trick. But I can use this instead. Okay, here's a question for you guys. Is there a way to like import strlen from strlen? Can somebody translate this to assembly or tell me if it's possible? Is there? There probably isn't, because it's literally just a label. Maybe there is. Who knows? Is there a way to import a function from another here, I'm just gonna start real chat. Okay. Is there a way to import another function from a function from another NASM x64 ASM file? Xturn. Is this right? Endcraft. Yeah, if you want, join the Discord. It'd be great. Lots of fun people on there. You've proven yourself quite helpful. extern my function. Is this how we do it? Global my label. Oh, we got to declare global first. So over here in strlen, you're saying I need to do this. Oops. Global string length. Although I feel like I should rename this, except there's no underscore either. Declare global first before extern. Okay, so I'm gonna do rename this to strlen to make it more short. Strlen, and then same thing here. Okay, that's good. And then over here, you're saying I can use extern strlen, but I need to link them together, at least according to this guy, right? Do you stand by this? Link them together, compile them separately and link them together. I mean, that makes sense to me. If you do it like that, then just remove start and have the function itself. Well, start has my test. Do you think it's worth keeping the test or not? I think I might hold on to the test just for the sake of being able to test it. But I do see what you're saying. That would be cool. You could just have standalone like modules almost, or like libraries. All right, let's try this. Wait, try what? Well, I can't really try anything until I've written some assembly here. Check Discord. Check Discord. Yeah, cool. That's what ChatGPT told me. Thank you. This is kind of the same as this, right? It's actually precisely the same. Thank you, though. So, might join later sounds fun, but I need to make an account first. Okay, sure, yeah. All right, extern. All right, so we can start using the strlen. So I'm gonna say, here's what I'm gonna say. I'm gonna say, okay, so call strlen. You just call it like that, I'm assuming, just like you would normally. Not sure if it'll link properly because both of them use global start. It's like how in C you can't have multiple files with int main. That does make sense. We'll give it a shot and then let it fail when it fails. But note to self, yeah, that's a good thought. Okay. Call stir, we call that, and so then that sticks the length of the string in Rx. Now we have the length of the string in RAX. And then the GigaChat is right. Okay, let me just write this out and then I'll fix that. So we have the length in RAX, and so then we can stick the length in RDX, right? So here, so now we have the length in RDX. Oops, what is this? The Debian manual. Whoa. That's interesting. All right. So then we have the length in here. We stick the code for right in here. RDI has our string, which we're the pointer of our string, which we're gonna stick in here. And then one, what was one again? That means, oh, right, to standard out specifically. All right, that's good. It looks cool. Do you go to college or just learn programming on your own? Me? I actually did go to college. I have a bachelor's in, I forget, applied mathematics. So college is a waste of time. Not if you do it the same time as high school. And then, but yeah, no, I haven't used a single thing I learned in college once, so it can be very much a waste of time. But I wouldn't generalize that to everybody. As far as programming goes, it's pretty easy to learn on your own. I mean, not easy, but like very doable. There's like so many free resources. Exactly. I have an elite team of advisors. All you have to do is go find strangers on the internet that are willing to spend hours every single day to teaching you for free. It's fantastic. You should try it. But no, yeah, I'm not going to college. I did go to college not for programming, for math, and all the programming stuff I've learned has been on my own. I have an uncle. I work with him. He's very, very good, and he's taught me a whole lot too, just like on a personal level. So there is a Discord server. Yeah, you should get on. There's a not in the description for this video because I haven't written that yet, but if you go to any of the other videos on this playlist or channel, then there's a link to get on the Discord. Yeah, Silo. Where was I? Okay, so this I think is good. I'm thinking, but you know that what I think isn't always right on. You're very welcome, Mohammed. And then start over here. We move into RDI, our test string, and then we print it, and then we exit. All right, we're gonna try this. Oh no, you said that we need to change start, right? All right, so we'll get rid of this test, right? For now. Can I just comment it out? Why isn't GC working for commenting? I don't know. Because I have to do oops. Do it the way our ancestors did it. All right, like that, kind of. And then do these together. All right, now our just thing isn't gonna work exactly. Unless I made another one for 2, and then I have to make another one for 3. Did you say you studied math, Kai? I did. I have a bachelor's in applied mathematics and a minor in physics, actually. But I love math. The data isn't needed. Oh yes, you're right. So I can comment this out too. Okay. Looks like your website is down. What's my website? kaijh.com. Oh, sure enough. Oh, I think I killed it the other day, and I forgot to redirect it. Applied math and physics, yeah. Thank you. Yeah, I took it down. I made another one. That's why I took it down. If you go to here, the new one is here. But I mean, there's nothing really there. It's just kind of a bunch of. There's nothing. There's almost nothing there. It just says what I'm working on, including this. Okay. So we're gonna run these. So NASM, am I in the right spot? All right, NASM. Today I learned Kai has a website. There's nothing on it, so there's not really a point in talking much about it. NASM -f elf 64, and then we're gonna do stir. Wait, which one? Print stir len.asm -o stir len.o, and then the same thing for print stir. All right, and now I need to, so I've got these two object files, and now I need to link them together, and I do that by doing this. Link print stir.o and stirlen.o, and then -o, and this is print stir. I think once you assemble stirlen once, you don't need to do it again. Next time, just link it. Okay, thank you. And then print stir, I guess. Perfect. Just what I wanted. 139. All right, we got a seg fault. What do we do now? Yes, let's go. Seg fault. Drink some water, Kai. I drank a bunch before this, and I am sort of getting thirsty. All right. We need. All right, I guess maybe I'll try debugging it, or I could look through this, or maybe I should get some water. I'm gonna get some water. I think I made a way to pause this, didn't I? Yeah. Okay. Be right back. Gonna get some water. Taking Zala's advice. I'm back. Exit code 11 water break. We need all the brain power we can get. Yeah, we do. Okay. where we left off, we have a not working file here, correct? Oh no, Neovan froze. Neovan froze. Hey, physics. No, I was a physics minor, not a physics major, so I'm not a physics nerd. I'm just a physics enthusiast. But I love it. It's fascinating. Quantum or relativity? I did take quantum physics. It's pretty interesting. It's kind of mind bending. All right, Neovan is frozen, so I don't know what to do. Open. Low energy particle physics. See, this guy's way smarter than I am. Schrodinger's cat is dead. All right, try this again. All right, this has been going on. This has been going for a long time. As soon as I get this print string thing working, I'm going to stop streaming. So, if that's good with you guys, I think that'll be a good stopping point. Oh wait, I had this big, didn't I? We need to get a resident quantum physicist on our Discord. Print. Okay. So this is not working. And we need to figure out why. So should we debug it? Let's debug it. So I need to build these things with debug symbols, right? NASM. Where am I? All right, assignments 1. All right, NASM. So then I have to do what? Dash F elf 64 and then dash yes, and then dash G and then dash big F dwarf, and then check the core dump. Debug the dump file. Oh yeah, somebody told me about this. The core dump. Should I check the core dump or should I just debug like this? Because this might be helpful. Let me try this first, and then I might check out the dump file. All right, which one are we doing? Stir. So we need both, right? So stirlen.asm, and they do the same thing for a print stir. It was Bacon who told me this. Oh, we have both of those, and then link them together like that. And then I want to lldb print stir, correct? Okay. Okay, now I want some breakpoints. Oh no, we do the start thing, right? Okay, so we'll go break point set dash dash name start. Perfect. And now we run. Cool. We already moved. It's doing that weird thing where it skips the one line already, but it's fine. So if I register read, is there like a shortcut for that? That'd be cool. Is there a shortcut in, or well, not a shortcut. What am I looking for? / alias for register read in lldb. No, it doesn't. You can create aliases. Whoa. We need like a config file. Okay, that's too complicated. There's always up arrow. Register read. Which one are we doing? RDI here. Sure enough, RDI has the address to test string 1. Help. Very nice. Okay. All right, so I'm gonna step. We step in the next. Wait, why? Because we went to print string. We went here. We already called strlen. Okay, so it's not jumping to there. So this is what we need to check. RAX should have the length of the string. So we're going to register read RAX. B. B is 11. So that's correct. That's cool. So that is actually working. The whole like extern strlen thing is working. And then we'll step. And now, if we read RDX, it should have that same B. Okay. And then we're going to move 1 into RX after we step, right? So then we read RX again. And it has 1, okay? Then we're going to move RDI into RSI. RDI. Wasn't RDI? It's still the pointer to that thing. Okay, and then we're moving that into RSI as soon as we step. So we're going to now read RSI. RSI now has the pointer. Awesome. And then we're going to... Oh. Okay, well there's some glaring problems with our code here. Like we're missing the syscall and we're missing the return. Isn't that kind of a big issue? Right. Yeah, okay. That's kind of funny. All right, let's try this again. You said I don't need to assemble strlen again. I can just do this guy, print str, and then link them together again. Hey, look at that. Totally worked. And all we were missing was the syscall and the return. Cool. Do we want it to print a new line afterwards? That wasn't exactly in the specification. But what we could do is this. If we change this to 10, right? 10 is new line in ASCII. And then try that again. Now we get a new line. Cool, that's super fun. Okay. Well, print new line is a separate function. Oh yeah, check that out. But for now, I can just tack on a new line to my string, and it'll work. Awesome, it's totally working. That's kind of a silly mistake. Thanks, Silo. So happy. I'm happy too. It's been super fun. All right, I'm gonna stop there. Next stream we'll do print char, print new lines, see how far we can get with these. Ooh, I haven't done any reading yet from standard in. That'll be fun. I did learn a lot. All right, cool. I'm going to stop the stream, and planning on tomorrow 6:30 Eastern Standard Time, but I'll let you guys know in Discord about times and stuff, and I'll schedule it. We all learned something. Lots of learning progress today. I'll have to check the start of the stream later. Cool, yeah. Yeah, thanks everybody. Super helpful. See you on Discord, and until the next stream.